Welcome, Scholar. Today we are tackling JAMB UTME Topic 1EI, the dimensions of physical quantities. Our objective is to learn how to determine dimensions and units using clear logic, rather than relying on memorization. The trap most students fall into is trying to cram the final, complex dimensions for variables like work, power, or pressure. When the exam clock starts ticking and panic sets in, those memorized letters and numbers often jumble together, forcing you to guess. We can bypass that trap by thinking of physical quantities like a building. A compound wall looks complex, but it is constructed from basic raw materials like cement and wood. In physics, every complex quantity is built from just three fundamental blocks: mass, length, and time. These are your fundamental dimensional symbols. M represents mass, L represents length, and T represents time. These three tools are all you need to solve dimension problems on the exam. Deriding a formula structurally allows you to reconstruct the logic on your own. While memorized strings of letters can fail during an exam, the relationship between these fundamental blocks stays the same. Let's build a derivation ladder, starting with velocity. The formula is displacement over time. This reduces to length over time, or L over T. To avoid fractions in standard form, we slide the T up with a negative index. It becomes LT to the negative 1. Next rung, acceleration. The formula is velocity over time. We substitute our velocity dimension, LT to the negative 1, into the numerator, dividing by T. Bringing the bottom T up combines the indices. Negative 1 minus 1 is negative 2. The dimension is LT to the negative 2. We didn't have to memorize a new string of characters, we just stacked our fundamental blocks. As long as you know the base formula, you can always determine the dimension. From the 2017 UTME, which of the following is the dimension of pressure? Let's solve it. Pressure is force divided by area. Force is mass times acceleration. Substituting blocks, mass is m, acceleration is LT minus 2, making force MLT minus 2. Now, an active recall moment. Pause the video and look at the denominator for pressure, which is area. Use your fundamental quantities to find the dimension for area. Welcome back. Area is length times breadth, meaning L times L, or L squared. Combining pieces, force over area. The top L cancels one bottom L. The remaining bottom L shifts up with a negative index, giving us ML minus 1 T minus 2. This methodical substitution removes the risk of a memory lapse. By relying on the base units, you can arrive at the correct result regardless of the formula's complexity. Comparing our result to the exam paper, we can select option C. Note option B, MLT minus 2 is the dimension for force. Examiners include this to catch students who find the numerator but forget to divide by area. There is one more benefit to this method. Once you have the dimension, you can find the standard SI unit by replacing the dimensional symbols with their unit equivalents. Mass, M, becomes kilograms. Length, L, becomes meters. Time, T, becomes seconds. Our dimension for pressure translates to kilograms, meters to the negative 1, seconds to the negative 2. Treating formulas as structures rather than static text helps reveal how different physical properties relate to one another across the syllabus. Excellent, Momentum Scholar. Your mastery of dimensions is confirmed. Return to the dashboard and take the mastery quiz to move your physics progress bar to 100%.